Y'all ever wondered where clouds come from? How they stay in the sky? How they be so long and big? Well, me too. Right here we got Neil deGrasse. Let's see what he say about it.
This one on clouds.
I wouldn't think there was a lot to talk about with clouds, and maybe that's why we haven't done it.
But have you looked at clouds from both sides now? You ever wondered why clouds are just up there?
Once I found out that clouds were basically water droplets,
Yeah.
just basically vapor,
Yeah.
they became extremely uninteresting to me at that point.
Okay, let me get your interest back going for you.
Okay.
Okay. All right. I have a pocket of air, and it has some humidity level in it.
Okay.
Okay. Let's say it's 50% humid. That humidity that is reported is actually a relative humidity.
Okay.
Okay. What that means is it is 50% relative to how much it could carry at that temperature. So watch. As the blob of air gets heated and rises,
Right.
the temperature drops.
Mm-hmm.
Colder air can hold less humidity than warmer air.
Mm-hmm.
So the relative humidity goes up.
Gotcha.
It starts at 50 in this example, it goes to 60, then to 70, then to 80. It is ascending. 80, 90. Bada bing! You reach 100%.
Right.
And boom, you have a cloud. That's why the cloud is up there and not down here.
And now I know how clouds are born. That's kind of dope, though.
So suppose there's no wind and you got, like, let's say 70% humidity.
All right.
The sun sets, temperature drops. Air temperature drops.
Starts to cool.
Right here, it drops right here.
Okay.
Gets to 100%. What happens? What just happened?
We made a cloud.
Where did we make the cloud?
Where the air is. I mean,
Thank you, Chuck, for that brilliant answer.
Yeah.
Right in front of me.
Yeah, of course. It would be right here.
Right here.
Yeah.
We have a new word for that kind of cloud.
Do we really?
Yes.
What?
Fog.
You got me.
It's fog.
But that's fog. And that's the cloud.
That's why when it's foggy, it's always a little cold.
Yes.
You ever notice that?
Yeah.
If the cloud formation is vigorous, like the temperature dropped real fast,
Right.
and it was really humid, and it comes up there and it's still being unstable and it's rising and it's turning into water droplets, you get a cumulus cloud.
Okay.
Okay? If this is intense and it's unrelenting and it continues to build, that cumulus cloud, which is just white with sunlight moving through it,
Right.
it become less white
Okay.
because the droplets are getting bigger and bigger.
Oh,
Okay? And it starts getting gray.
nice.
We have a gray cumulus cloud. You get cumulonimbus.
Okay.
That stuff will hurt you.
My only thing about this is like what's causing all that. Like I was telling my daughter the other day actually. I was like once the cloud gets a little too heavy, that's when it start dropping raindrops. But from our point of view, it don't look like the cloud has any weight at all because it's floating in the air. The cumulonimbus.
So the cumulonimbus, now the water droplets it is so laden with water,
Right.
it cannot contain the humidity,
Right.
even at 100%. And so the humidity nucleates, it finds droplet, dust in the air, things. It says, and other bits of water vapor collect to it. And it's held there for a while because you have updrafts, because that's how you made the cloud in the first place.
Right.
But then it gets so big it drops out.
Nice.
So the more vigorous the cloud is, the heavier the raindrops are.
Uh-huh.
Because it was holding them up.
Right.
Okay?
Right.
The very fast-moving air is holding it up until it can't hold it up anymore, and that big fat-ass drop falls out of the sky, and you get the big drop, thunderstorms.
Nice.
Okay? Now, let's say it's even more vigorous than that.
Uh-oh.
Now, imagine updraft so strong that not even the raindrops can fall out. And it just stays up there. The thing freezes and gets bigger and bigger. And then one day say, I can't hold you anymore. I gotta let you go. And now it's too big to melt.
Oh my God.
And what do you get?
You got hail.
Hail.
You know what's crazy? My economics teacher, actually, he was telling me how humidity and the temperature of rocks actually can create storms. And he was saying that all of the storms that happen over here, I'm over in Savannah and Hinesville, or Fort Stewart. He said it comes from Atlanta. It it forms there, and then it comes here. And once me and my wife, we go to Jacksonville a lot, and it always rain in this one spot on the highway, and it's crazy, bro. And this makes sense. So precipitation, all that stuff there.
That's terrible.
You got hail.
Mm.
It's all because of the updrafts.
Right. That's
Updrafts.
an insurance cloud.
My car was in hail once. You get all these pock marks
Yeah,
on
that's
your
what
car.
I'm saying. Yeah, that
Your car looked like somebody popped it.
looked like
100
you were in
times.
a bad relationship.
That means the bigger the hail pellets, spheres, the more severe the storm was.
Right.
Because it meant the updrafts were just so significant. It was so catastrophic, turning just moist air into
Giant balls of ice.
Giant balls of ice. That's right. Damn. And it's why you don't have to be in cold climates to have hail, frozen water come out, because it's coming from a part of the atmosphere that's that cold no matter what. In the summertime as well.
Yeah, right. Yeah.
Right. So those are big puffy clouds. Cirrus clouds they can be transparent, but they mess with our viewing of the night sky.
Little wispy thin clouds.
Things. Right. And these are clouds that just hang out up there, and they're just they're very stable, cirrus clouds. And then you have weather fronts that come in where there's a change in temperature. You never heard of a warm front coming in bringing bad weather.
Right.
That's not how that works.
It's always a cold front.
Because if things get warmer, you're going to hold more moisture.
More moisture.
It's when the cold front comes in.
Right. Messing up everything.
And you had warm air that had moisture,
Right.
and they meet at the boundary. It turns your moisture into rain, into storms, into clouds.
Right.
And so it's always the cold front you got to watch out for.
It's the drunk uncle at the cookout. The cold front. It's messing things up.
All right. So just one other interesting thing, I think.
Okay.
These are especially visible in airplanes. You see these long, I'll call them columns, but they're horizontal columns of clouds,
Yeah.
one after another.
Yes.
These are called cloud streets.
Cloud streets?
Streets.
Okay.
Cloud streets. The air goes up, but wait a minute. If air is going up, what's replacing that air?
Got to be more air.
More. Thank you, Chuck. That brilliant answer. Okay. So for every bit of air that goes up, there's air that drops
down.
and comes in to fill the gap. Okay. So these are convective cells. It's okay. That's what's happening here. But in a cloud street, the convective cell is cylindrical.
Interesting.
Okay. So imagine a horizontal cylinder that's rotating.
Oh, nice.
Okay. On the side that's rotating up, you get cloud formation. And on the side that's rotating down, no clouds form.
Right.
Because it's downward air. We've been through that.
Right.
Okay. And so, but wait a minute, how about the other cylinder? It has to be turning the opposite way.
direction. Yeah.
Otherwise, they would cancel.
Right.
You can have up air and down air simultaneously in the same place. So these cloud streets.
I'm gonna start recording right here.